The pace of tech innovation, it's just breathtaking sometimes. And AI right now, it's on absolute fire.
It really is.
Just think about this. The AI chip market, maybe $50 billion back in 2022. Fast forward just 2 years to now, 2024, it's looking like $85 billion.
Wow. That's fast growth.
And here's a real kicker. NPUs, neural processing units. They're projected to be a $100 billion market by 2030, growing, get this, 35% every year.
Astounding numbers. Yeah.
So, I mean, if you want to get a handle on where tech is going, understanding this growth engine, it feels pretty crucial.
It is indeed. And that engine, as you say, it's really these neural processing units and other specialized AI accelerators. They are basically the silicon brains making this whole AI revolution happen.
Exactly.
So in this deep dive, we're going to, demystify what these NPUs actually are, and maybe more importantly, why you should care that they're popping up everywhere.
Yes. Exactly why you should care. And look, we've been digging into some really fascinating stuff for this. We've got these in-depth market analyses, looking at the companies, the stocks, who's investing heavily in NPUs.
Right, the big players.
Yeah, it gives you a feel for the money side, the innovators, people like Intel, AMD, Qualcomm, but also like ARM and Synopsys doing the core design.
That's IP architects, yeah. Crucial. And the cloud giants too, right? Google, AWS, they're building their own custom chips now.
Right, and to get the whole story, we're also diving into, the nuts and bolts, the actual architecture of NPUs.
How they work fundamentally.
Yeah, how they're designed, what's inside, the clever tricks they use to get that amazing performance and save power doing AI stuff.
So you get the big picture strategy and the tech details.
That's the plan. Our goal today, pretty simple. Cut through the jargon, make it clear, engaging, hopefully give you a few aha moments without, drowning you in tech speak.
Sounds good. Let's do it.
Okay, let's get right to it then. Fundamentally, what is a neural processing unit, an NPU?
Okay, so at its heart, an NPU is a special kind of chip. It's a microprocessor or sometimes called a hardware accelerator, specifically built to speed up AI. Machine learning too, but especially deep learning.
Like a custom engine just for AI.
Exactly, a custom engine. You'll hear other names too. AI accelerators, AI chips, deep learning processors. They basically all mean the same thing.
Okay, so what's its main job? What kind of AI tasks does it actually speed up?
Its primary function is really cranking through the heavy math that AI relies on. Things like huge matrix multiplications, vector operations, convolutions, applying activation functions.
The really repetitive, intense calculations.
Precisely. They are the absolute bedrock of most deep learning algorithms. It speeds those up dramatically.
Gotcha. Now you hear inference and training thrown around a lot with AI. Where do NPUs mostly fit?
Good question. Very important distinction. So while some really high-end AI accelerators, like the ones in massive data centers, can handle training models, the NPUs you find in, say, your phone, your laptop, most everyday tech, they're mainly focused on accelerating inference.
Inference being running the already trained model.
Exactly. Taking a model that's learned its stuff and using it to make predictions, classify things. It's the using AI part. And in those devices, speed is critical. You need answers fast.
Real-time responsiveness, yeah.
And power efficiency. Hugely important. Can't drain your battery in 5 minutes.
Right. Okay, so we have CPUs, our computer brains. We have GPUs, the graphics cards, which also do parallel stuff. Why did we need this whole new NPU thing? What were the old chips bad at?
That really gets to the why. So CPUs, your central processing units, they're fantastic generalists. They handle tons of different tasks, run instructions one after another, manage the whole system.
The main brain.
The main brain. But they really, really struggle with the mass amount of parallel math that modern AI demands. It just overwhelms their sequential nature.
Okay, and GPUs, they do parallel stuff for graphics.
They do. And that's why they were cleverly adapted for AI, especially training. Their parallel structure was a good fit, but they could be power hogs. And they weren't originally designed for, say, the specific ways data moves in AI inference, or the fact that inference often works great with lower precision numbers. Especially on battery power, GPUs aren't always the most efficient tool for inference.
So NPUs were built to fill that gap.
Exactly. Purpose-built to tackle AI workloads way more efficiently. They deliver much better performance for every watt of power you feed them, bridging that performance per watt gap.
It's like having a specialized tool, right?
Yeah.
Instead of a Swiss Army knife.
I've also heard people say NPUs are kind of inspired by the human brain. Is that just marketing or?
There's definitely a kernel of truth there. It's not a direct copy, obviously, but the design philosophy often emphasizes things like processing data in parallel, lots of connections, efficient pathways, similar in concept to how artificial neural networks are modeled, and loosely how we think the brain works.
So the focus is on parallel data processing, yes, and optimizing the paths for those specific AI calculations. It's about mirroring that network structure at the circuit level.
Okay, so CPUs get bogged down by the sheer parallelism. GPUs have the parallelism, but maybe aren't the most power efficient or perfectly optimized for inference data flow.
Right. They have overhead from their graphics origins, might not be ideal for low power inference, especially with lower precision math.
And NPUs are stripped down, laser focused just on the math behind neural networks.
Precisely. Designed from the ground up for that job, leading to that big performance per watt advantage we talked about.
And that brain analogy, it's not just fluff. It points to maybe a different way of designing chips, more about parallel connections, data flow, maybe blurring the lines between processor and memory a bit.
Exactly. It reflects a shift towards architectures that are inherently more suited to the massive parallelism and data movement patterns of AI, maybe even moving away slightly from the strict traditional separation of CPU and memory we see in classic von Neumann designs.
Interesting. Okay, we've got a decent feel for what an NPU is. Now let's really pin down the differences. NPU versus CPU versus GPU. Let's start with the CPU again. Remind us of its core role and why it's not the AI champ.
Sure. The CPU, general purpose brain. Great at sequential instructions, complex logic, making decisions, running the operating system, usually has a few very powerful cores designed for low latency single tasks.
But not built for thousands of parallel math problems at once.
Not at all.
Yeah.
That sequential nature is its weakness for deep learning's massive parallelism. It handles the control parts of AI, the non-parallel bits, but it's just inefficient for the core number crunching.
Right, like using a master craftsman for an assembly line job. Okay, GPUs. Graphics origin. Lots of simple cores, good for parallel tasks, great for training, but the downside for inference.
Their strength is that high-throughput parallel processing, doing the same simple thing to lots of data, perfect for graphics, and adapted well for AI training's matrix math. So yeah, GPUs dominate training in data centers. But for inference, especially on your phone or laptop, they're often less power efficient than an NPU. Their architecture still has graphic stuff, maybe not perfectly tuned for inference data flows or low-precision math. Modern GPUs do have specialized AI bits, like NVIDIA's tensor cores,
Right.
but their overall focus is still broader than a dedicated NPU.
Okay, GPU. The powerful, adaptable parallel worker, great for training, but maybe a bit overkill and power-hungry for inference on the go. Which brings us back to the NPU. Contrast it. What's its unique selling point?
The key is purpose-built. NPUs are often ASICs, application-specific integrated circuits or specific blocks within a larger chip. And so the job is accelerating AI and neural nets.
They trade versatility for efficiency.
Exactly. They ditch the general purpose stuff of CPUs and the graphic stuff of GPUs to be extremely efficient at AML. Architectures built around neural network data flow, parallel structures like systolic arrays, optimized memory, hardware support for low precision.
All geared towards AI.
All geared towards AI. They act as co-processors. They don't replace the CPU or GPU. They work alongside them in these heterogeneous systems. They offload the AI work.
And the benefits are?
Better AI speed, the whole system feels more responsive because the CPU, GPU are free, and crucially, much better energy efficiency, their main strength. Efficient, low latency AI inference, especially on edge and mobile devices.
That makes total sense. The specialist joining the team, we've got a table summarizing this. Maybe pick out one or two really stark contrasts for us.
Sure. Look at, say, architecture type. CPU is general purpose. GPU is highly parallel, graphics focused but adaptable. NPU is highly parallel, but specifically AML focused, often using things like systolic arrays.
Very different designs.
Or look at primary strength. CPU, versatility, complex tasks. GPU, massive parallel throughput, great for training. NPU, extreme power efficiency and performance for AI inference.
Yeah.
That specialization really shines through.